Welcome to this class. This class we're going to discuss about the sum and difference rule for differentiation. This is our fourth rule, the sum and difference rule. Now, this is how the rule states. So if u and v are differentiable functions of x, then their sum so maybe say this is sum rule at A, then their sum u plus v is differentiable at every point where u and v are both differentiable. At such points, d dx of u plus v is given by du dx plus dv dx. So in functional notation, if u is f of x and v is g of x, then d dx of u plus v is the same as d dx of f of x plus g of x, which is df dx plus dg dx. So this is what we call the sum rule. Either this or this. Now the second part, the difference rule. Difference. So that if u and v are differentiable functions, of x, then the difference u minus v is differentiable at every point where u and v are differentiable, and at such points d dx of u minus v is du dx minus dv dx. So this is what we call the difference rule. Similarly, in functional notation, if u is f of x and v is g of x, then we can as well write that difference rule as d dx of u minus v is du is the same as d dx of f of x plus minus g of x, d dx f of x minus g of x, which is dx minus dg dx. So this another way of writing the difference rule. Now let's see some examples on how to apply difference rule and a sum rule. So examples. Find dy dx given. So a, y is x power 4 plus 12x. And then b, y is x power 3 plus 4 over 3 x power 2 minus 5x plus 1. C, x squared minus sine x. And D, y equals to 5 e raised power x plus cosine of x. So solution to these problems, for this one, dy dx, we use power rule on each term. So this will be 4, and then 4 minus 1 is 3 plus 12. And then this other one, dy dx, using power rule, first term will be 3x squared. Top 2, we have 8 over 3 x, and then minus 5. Derivative of 1 is 0, so we don't have to include it. This one, dy dx, is given by, first term by power rule, we get 2x. Derivative of sine function, we have derived the answer to be cos function. So it will be 2x minus cos x. This one, dy dx, will be derivative of e raised power x. We have derived it is e raised power x. Derivative of cosine is negative sine. So those will be the solutions to those 4 problems. And then finally, E, the question is, does the curve y equals to x power 4 minus 2x squared plus 2 have any horizontal tangents? If so, where? So this is a good problem. It requires us to find the derivative and then know that saying horizontal tangents, the value of the gradient of the derivative should be 0. So solution, first thing, horizontal tangents implies that dy dx should be 0, or the slope should be 0 for the horizontal line. So dy dx for this question is 4x x power 3 minus, using power rule, 2x squared will be 4x and because we are interested in the horizontal tangent, then we equate this one to 0 to find the values of x. So we factor out 4x into x squared minus 1 equals to 0. So this implies x dividing through by 4 into x minus 1, x plus 1 equals to 0, because this is a difference of two squares. So that's why it has these factors, x minus 1, x plus 1. And this product of three linear terms implies that x equals to 0, x equals to 1, and x equals to -1. So the points, so when x equals to 0, y will be given by 0 power 4 minus 2, 0 squared plus 2. This gives us 2. When x equals to 1, then y will be 1 power 4 minus 2, 1 squared plus 2. So this will be 2 minus 2 plus 2, 0. So this will be 1. And then when x equals to -1, y will be -1 power 4 minus 2 minus 1 squared plus 2. This 1 minus 2 plus 2, which will give us 1. So the points are, so the answer is yes. The curve y equals to x power 4 minus 2x squared plus 2 has horizontal tangents at the points. So remember, when x was 0, y was 2. When x was 1, y was 1. And when x was -1, y was 1. So those will be the solutions. Thank you.